Ninth chemistry, chapter number 1, topic 1.5, differences between elements, compound and mixture. First, we discuss elements. An element is the simplest form of matter. It is a pure substance containing the same kind of atoms. A compound is a pure substance. It is formed by the chemical combination of two or more atoms of different elements. Mixture is an impure compound, a mixed sample of matter having more than one type of element or compound mixed together in any ratio is called a mixture. Second difference, it is in element. It is not possible to break down an element into simpler particle by ordinary chemical reaction. In compound, the atom of element must combine together by a fixed ratio by weight. For example, in water, hydrogen and oxygen are present in a fixed ratio of 1:8 by weight. But in mixture, each component of a mixture retains its identity and specific properties. Third difference, when an element exists in the form of atoms, it is represented by a symbol. For example, sodium and calcium are represented by their symbol sodium Na and calcium Ca. In compound, it is possible to break a compound into its constituent element by a chemical reaction. For example, ammonia can be converted back to nitrogen and hydrogen by a suitable chemical reaction. In mixture, a mixture may be homogeneous or heterogeneous. For example, the solution of common salt in water is a homogeneous mixture, while a sample of rock is a heterogeneous mixture. The fourth difference, gaseous element exist in the form of independent molecule. For example, nitrogen N2, oxygen O2 and chlorine Cl2. Noble gases, however, exist as monoatomic molecules. For example, helium He, argon Ar. In compound, the properties of compound are always different from the element from which it is formed. For example, the properties of water are different from those of hydrogen and oxygen. The component of a mixture are not chemically bound together and they can be separated by physical method. Last difference, compound exist in the form of molecule. For example, hydrogen chloride HCl, ammonia NH3 and water H2O. Compound may also exist as network arrangement of their atoms. For example, ionic compound like NaCl and covalent compound like sand SiO2 silica. The properties of mixture are the sum of those of its component. Topic number 1.6, solution, colloidal solution and suspension. First of all, define solution. Solution is such a mixture in which solute particles are completely homogenized in the solvent. For example, copper sulfate in water. The solute particle in such a solution cannot be seen by the naked eye. If solution is filtered, these particles pass through the pores of filter paper, leaving no residue. Such a solution is called a true solution. A suspension, on the other hand, is a mixture in which solute particles do not dissolve in the solvent. We can actually see these particles. If a suspension is kept for some time, these particles settle down again. If this suspension is filtered, the particle in it cannot pass through the pores of filter paper and can be collected as a residue. A mixture of chalk in water is an example of suspension. Beside a true solution and a suspension, there is a third form of solution called colloidal solution. In this type, the solute particles do not homogenize with solvent. These particles are a little bit bigger than the solute particle present in the true solution, but not big enough to be seen with the naked eye like the particles present in a suspension. If kept for some time, the particles of a colloidal solution do not settle down. On filtration, these particles pass through the filter paper like the particle of a true solution. Starch solution and white of an egg are the common example of colloidal solution. Topic 1.7, formation of unsaturated and saturated solution. Take about 100 gram of water in a beaker, add to it 5 gram of table salt and stir it. The sugar will dissolve in water, then add another 5 gram of sugar and stir. This will also dissolve. This solution is called an unsaturated solution. Define. A solution which can dissolve more amount of solute at a particular temperature is called unsaturated solution. Continue adding sugar in the above solution. As the quantity of sugar in water increases, its its solubility will become more difficult. A stage comes when no more sugar will dissolve in water at this temperature. Any more sugar added at this stage will settle down at the bottom of the beaker. This solution is called saturated solution at a particular temperature of the process. A solution in which maximum amount of solute have been dissolved in a particular amount of solvent at a particular temperature is called a saturated solution. Different solute have different solubility in a particular solvent. For example, if the solution of table sugar and sodium chloride are prepared, it is found that 36 gram of NaCl can dissolve in 100 gram of water at 20 centigrade temperature to give a saturated solution. Against this, 203.9 gram of table sugar can dissolve in water at 20 centigrade temperature to give its saturated solution. In other words, the solubility of table sugar in water is far greater than that of sodium chloride at 20 centigrade. This is due to the fact that sugar molecules are larger than salt ions, so more water molecule can surround a single sugar molecule, causing it to dissolve in larger amount. Topic 1.8 Effects of temperature on the solubility of solutes. The solubility of a solute is the amount of solute which can dissolve in 100 gram of a solvent at a particular temperature. Change in temperature have different effects on the solubility of different compounds. Usually the solubility increases with the increase in temperature, but it cannot be taken as a general rule. There are a large number of compounds whose solubility in water increase with the increase in temperature. For example, potassium nitrate, silver nitrate, and potassium chloride. The solubility of sodium chloride in water does not increase with the increase in temperature. The solubility of compounds like lithium carbonate and calcium chromate decrease with the increase in temperature. The solubility of gases in water also decrease with the increase in temperature. Similarly, the solubilities of copper sulfate and sodium nitrate also increase with the increase in temperature. However, the solubility of calcium hydroxide decrease with the increase in temperature.